Okay, so this is the review for lesson 3 for Kirchhoff's law. So you can have a scrap sheet of paper and try this out, and then pause the video, try out the question before you check the solution. So this part is talking about Kirchhoff's law for voltage, and we talked about that there will be two things that you need to look for, right? Every time when we're dealing with voltage, we're gonna have to look for a loop. Okay, a loop. What happened is the voltage increase, or sometimes we say voltage gain, have to equals to the voltage lost. And so voltage gain equals to voltage loss. So if I were to take a red pen and I'm going to start at the battery and we're going to go around the loop, doesn't matter which loop you take, okay? So I'm just going to go the inner loop. So I'm just going to say that the electrons went through all these things. And the part that is going to cause the gain would be the battery. Battery, we have one of them that's called VT. V loss happens at the load. So we got at the red line, we got the 25 volt, the V1, the V2, and the V5. So V1 plus V2 plus V5. Because it didn't go through V3, V4, or V6, we're not going to add that. If you draw your line differently on a different path, you include the one that your path goes through. But anything that didn't go through, we don't include it into the equation. Okay, so let's see where it takes us. So I got 60 equals V1, which is 25, plus V2, I don't know what it is, plus V5 is 10. So I'm lucky enough that I actually already have enough information for me to solve for one of them. And if there's time that you don't have enough yet, that's okay. Do the other equations, right? Because there's two things that you're checking. You're checking loops and you're checking for parallels. So right now I'm just going to solve for my V2. Okay, so what you do is you rearrange the equation, right? So you take your 60 minus your 25 minus your 10. So my V2 is also 25 volt. Okay, so that's the first thing you look for. Kind of the second rules you look for a voltage when I'm using Kirchhoff's law is I'm looking for anything that are parallel to each other, because if I have that parallel, I know that the voltages are the same. And in this circuit, there are two parallel. There is one parallel that is very obvious, is the one that's at the bottom, right? Like these two, I know they're exactly just parallel to each other. So I can say that V5 and V6 have to be the same. And because I know V5 is 10, so that means V6 is also 10 volt. Okay, done. But the other tricky one is you actually still have another parallel loop. I'm going to pick blue and I'm going to circle this for you. This two path, it's also a parallel path. Right, so it's not going to be V2 equal V3, but what it is now V2 is actually the same as V3 and V4, because V3 and 4 together are parallel to the V2. So I got 25 as my V2. I know V3 is 15, and then I got V4 there, so V4 worked out to be 10. Okay, so I think I found everything there. Are we okay? So you always check for loops and you always check for parallel when we're dealing with voltage. Okay, so another review. This is still Kirchhoff's law, but I would like you to do it for the current. So there are two things that you would be looking for the current, right? So we always look for any resistor that are in series, any of the current that are in series with each other. Okay, so the first one that I hope you can pick out is these two. Do you see how that's one continuous path? If you want to extend it all the way, anything along this green line are in series with each other, meaning they have the same current. Okay, so what that means is the rule says if I have anything that are in series, all the currents are the same to each other. So what that means is I can say that I1, I'm going to use a green pen. I can say that I1 and IT are the same because they are in series with each other. So I know that IT is 25. That means I1 is also 25 amps. Okay, so I found that. Okay, but there is actually another one that are in series with each other, which are these two. There's still one path. I know that there's a split right here. We're going to talk about that in a minute. Okay, but after it got split, there's actually this thing in series. So what I can also say is that I3 is also the same as I4. But at this point, I don't have a value for either one of them, so I don't actually have an answer. So that means eventually I will have to get back to that. Okay, so that means you now need the other rule. Okay, so we've done the series. Now what we need to look for are things called the junctions. And the rule says at junction, this is a junction, right? So we talked about the dot. So the green line comes in and it will split at the blue dot. Okay, at the junction, the rule says that the currents that are flowing in, I have one current that are going in. The name of that current is still I1. See how it stays the same until it encounters something else. And then it always have to equal to the current that are flowing out of it. I got two currents that are flowing out of it. Okay, what are the names of the two currents? So let's work this out. I am now focusing on the dot that is the blue dot. And the name of the current that are coming in is called I1. I1 is flowing into the blue dot, and then there's two that are coming out. Okay, there's one that is coming down this way, right, which is called I2. And then there's one that is going down on the other side, which is called the I3. I don't write I1 equals I2 plus I3 plus I4. I know that is easily mistaken because there's an I4 here, but basically you're only focusing at the point right at the junction. So if I were to draw like an outline of where you're focusing on, you basically only look at this part, okay? The part that is directly going in and directly coming out. It changed name, but it's still the same current, right? Like the I4 is the same as the I3 as we set up there. So I'm not going to include both of them. There's one current coming in, two current that are going out. Okay? All right, so there's another junction. The other junction is right here. See there is a split, right? There's a current that's coming in here, and then there's two currents that are coming out. I'm just going to use different colors. So I'm going to use this that's coming out this way. See how to the top, but then I have another one that is coming down this way, right? So there's one going in, two going out. Okay, so I'm going to repeat the equation. All right, but what's the name that's going in? That's my question for you. Is what is this name? What did you put that it is? Okay, if you look back to the parallel circuit that is on the right hand side, I got a blue dot and it got split. See the new dot that I'm drawing at the bottom actually got rejoined. So if I flip the equation, if I look at this equation, if I flip the equation, I2 plus I3 that is going into this blue dot, what does it have to come out with? This is the tricky part. You need to realize that this, it's the same green path. That is the same green path on the other side. This actually is still I1 because it got split at the blue dot and it got rejoined at the blue dot. Okay, so the new equation that I'm writing is actually I1 that is going in equals to the two dots that are coming out, which is a purpley thing, which is I5, adding the yellow, which is the I6. So those are the new equation. Okay, so two splits and anything that are in series. So those are the things you're looking for. So now let's finish this up. Okay, I know I1 is 25. So I'm just going to do this question right here. Okay. I know I1 is, so I'm going to rewrite this. I1 is I2 plus I3. I know I1 is also 25. I know I2 is 10. Solving for I3. I3 is going to have to be 15 amps. And when I found I3 at the top here, I also can say that I4 also have to be 15. So I found the I3 and the I4. And then now finishing up with this other equation. I'm just going to change color. Say let's do blue. Okay, so let's do blue for this. I1 is still 25. I know I5. I don't know I5, which is an unknown, but I know that I6 is 12. So it worked out that I5 is 25 minus 12 gives me 13 amps. Okay, so hopefully this helps you clear. I find that people sometimes have a hard time understanding the rejoining of it, and also what is in parallel, what is in series. That's also something important that you need to get used to. Okay, now on to lesson 4. We're talking about resistance. Okay, and we We learned this in grade 9, so I'm going to go fairly quick on it. It is just a straightforward equation. So basically, they're telling you that Ohm's law, voltage and current are proportional to each other. And the equation is written out to V is equals to I times R. So the resistance is basically dependent on, say, either a light bulb or a motor. So whatever the amount of current for this particular appliance will give you this amount of voltage. So they're just basically telling you that it is proportional to each other. And we already talked about voltage. Voltage is measured in volt. We already also talked about current, which is measured in amperes. Resistance R, we sort of mentioned. The unit is measured in ohms, and it has a symbol of little omega. So I don't know if you remember, but from lesson 2, I suggest you start a chart. Like, remember we were doing the chart of the symbol and the name and stuff like that. So R stands for resistance and is measured in ohms. You might want to add this to your chart from lesson 2, but I think it's quite straightforward that you will remember that. Okay, so the equation is V equals I times R. And so examples number 1. So these are just straightforward, just keeping things in SI unit. And they tell you that the voltage, so let's read through the question. Calculate resistance of a load with a voltage of 25 volt and a current of 410 milliamps. So we're asking for resistance, and they tell you voltage is 25, and the current, symbol is I, 410 milliamps. So we want to change that into amps. So from milli to the base unit, you divide it by 1000. Okay, so it's 0.410 amps. Equation is V equals to I times R. 25 is equals to 4.410 times R. Rearrange the equation for R. So 25 divided by 0.41. So it worked out to be 60.9756. So let's check. I need 2 sig, so 61 ohms. I guess the only thing tricky is that do you remember the unit is ohms. The other thing is, do you remember to convert it into SI unit? Okay, and we're going to talk about a whole bunch of resistance. If I have a whole bunch of resistors together, what would the total resistance work out to be? So so let's explain this equivalent resistance in a little bit with an example that's written down here. Equivalent resistance is if you see the resistance, they're telling you that you got R1, resistance for the first resistor. R2 is the resistance for the second resistor, R3 and R4. They're all separate. But they're asking you, how about the overall? If I were to say at the battery, what would the total resistance that it is going to feel from all of these resistance all acting together? How will they impact the overall total resistance of the circuit? That's what equivalent resistance is. And there are certain, couple of rules to explain to you. Okay, there's something wrong with my screen here, but that's okay. What I do need you to know is that to find the equivalent resistance for anything that is connected in series, RT is R1 plus R2 plus R3. Okay, you get more experience with it after I assign the gizmo. It actually tells you to go through where the rules come from and stuff like that. Okay, all right. And then for things that are in parallel, this is the equation that you would use. Okay, I hope yours is showing up, but mine is not. Okay, but basically what they do is they're telling you that in Ohm's law, for the Kirchhoff's law of current, if I have a current that's coming in, this is IT, it will split into I1 and I2 and I3. And since I know V equals to I times R, if I replaced it, I know that VT is, I know that each of them can be replaced by this. right? So that's based on subbing in the I is voltage divided by R, and we sub it into the first equation. And then because these are all in parallel, and we talked about that in parallel, all the voltages are the same, meaning VT and V1 and V2 are the same. They're all common. They actually could cancel off each other, and that's where the last equation come from. I would never ask you or expected you to know where it came from, but I need you to know if I have anything that are in parallel, this is how I work out the total resistance. All right, so for resistor connecting in series, where they tell you the different values for each of them and they want you to calculate the equivalent resistance. Whenever they're asking for the equivalent resistance, meaning they're asking for what is RT. And because this is connected in series, I just add them all together, and that's the equation. So 41 and 51.75 and 11.1 and 102.008. Add them all together. 205.858. I guess the only trick to this question is recognizing they're in series, add them all together, and then put it in the correct sig dig. There's 2 sig digs in this question, so 210, and know the unit is ohms. Okay, the next one is 3 resistors that are connected in series. Okay, so you got 3 resistors, they're connecting in parallel, and each of the resistors are given to you, and they want you to calculate the equivalent resistance. Knowing that we're talking about a parallel circuit, the equation for the resistance is 1 over RT, it's the sum of all the inverse. Okay, plug it in. So 1 over RT is 1 over 15 plus 1 over 12 plus 1 over 10. So I now want you to pause the video, figure out what is RT, and I'm going to tell you what my answer is. I don't know if you know how to punch this in. You've learned how to do this in grade 10. When we did the thin lens equation, working on the inverse, we did talk about how to get it, okay? I want RT. I don't want 1 over RT. I need to know what is the total value. Okay, so I got, okay, I think I'm messing this up. 12. So you should get the answer 4. So 4.0 is what you should get. Did you get that? All right, so let's bring in some calculator. I just took some screenshot. This is humongous. Okay, hold on. Okay, this is the calculator that I use. I don't know what calculator you guys use. I don't know if it's similar. Okay, but find on your calculator, I need you to find certain button. Okay, either this one, ANS button, or this one, the inverse button. Okay, so when I do the math, okay, so I'm just going to retrace the step. I'm going to just erase this. So what I do is I literally would punch the right hand side on the calculator. So let's just restart. Okay, so we're starting from this step. And unfortunately, I can't show the punching in the calculator for you on my screen right now. So you're going to just have to listen. So you clear everything. I wouldn't even use the fraction buttons. I would honestly just go 1 divided by 15, adding 1 divided by 12, adding 1 divided by 10. If you punch that in, you should have gotten an answer of 0.25. Like, I'm just going to write this out. You don't have to write it out. I'm just showing you the step. Did you get something like that? When you punch in the right hand side, just 1 divided by 15 plus 1 divided by 12 plus 1 divided by 10. You got that. Okay. To get the RT, you actually need to find the inverse. You need to go like this. Okay, that's what you need to do. So what you could do, there's a couple of ways that you can do that. You can take this number after you press the equal sign is basically what is stored in the A and S button. Okay, so what you do next is to get RT, what you would do is on your calculator, you literally would punch in 1 divided by A and S. The answer that's stored in it, you should be getting something like a 4. Another way that you could do, this is the alternate way you could do, is you can use the inverse button as I indicated here, right? The x minus 1 sometimes is a 1 over x button. It depends on what your calculator is. Everything is different. So I always just like to use my ANS button because that's the easiest one for me. Okay, I just go whatever I got, punch it in, press equal, and then I go 1 inverse, like divided by the answer. So the other thing you could do is take the 0.25 and you literally would punch the x minus 1 button and press equal. You should also get 4. So it's up to you how you want to do this. You probably need a little bit of practice. So that's the one that I would use. So let's bring in another calculator. I think I screenshot another one. I think this one also has an inverse button. Let's just see. Okay, if I cover this up, yeah, so the inverse button is right here. Do you see that? All right, sometimes they're hidden like tiny guys, right? You got to look around, but if you don't have it, you will have an ANS button that you can always use. Most of the calculator now has the ANS, the answer button, so whatever you got from before, okay? So we tried a series one and a parallel one. We're now going to move on to a compound. Okay, compound circuit. Okay. All right, let's take a look at this. You got a whole bunch of resistor there. Are they in series? Are they in parallel? So that's what you need to figure out, right? Do I add them all? Do I divide them all? This is actually a mixture of it. Okay, so let's talk about what is in series. And use the same green thing. Okay, this is in series with each other. Do you agree with it? Okay, but then connected in parallel with these three guys. And so basically, the green and the blue are connected in series with each other, but within the blue, they are parallel. Okay, so let's just recap this. Okay, R2, 3, and 4 are actually connected in parallel to each other. There are the branching. But then, at the same, if I call this all together, but then at the same time, the total resistance is actually R1 adding whatever the sum of the R2, 3, and 4 adding the R5. So these are in series with each other, with the exception that I need to figure out separately what the parallel is first and then hooked it in series with the rest of the circuit. Okay, so it's a little, you got to do it in steps. There are ways to do it in one step, but I'm not going to do that right now. So on the side, I'm going to do questions like R2, 3, and 4, like example number 2. So let's do that on the side first. Okay, so I know that the R, not quite total, I'm just going to call it the total for 2, 3, and 4, is the sum of the inverse of the 3 of them, right? Because they're connected in parallel, so I have to add them all together. So R2, 3, 4 in total is going to be 1 over 75 adding 1 over 50 adding 1 over 30. Okay, so take your calculator. So I would first of all punch in 1 divided by 75, adding 1 divided by 50, adding 1 divided by 30, and I would press equal. Right now I should have 0.0666666. Did you get that? Okay. Then I want to figure out what R2, 3, 4, not the inverse of it. So what I do is I go 1 divide ANS, whatever the answer that's stored in my calculator, and it should work out to be 15 ohms, right? So you can also use the inverse button. When you got the 0.0666666, what you do is you can then press the inverse button and press equal. That will also give you 15. Okay, and then finally, finishing this question up, now the total resistance, the equivalent total resistance is going to be R1, which is 12, adding the 15 that I found from before, and then adding the R5, which is 18. Okay, so it worked out to be 12 plus 15 plus 18, and so 45 ohms is the total of this.